We wanted to know if we could create a model which would give us an accurate value of g. Since the motion of a shuttlecock is similar to a parabola, we can use a quadratic to model the motion. Firstly, we consider this video of an underhand badminton serve. We use measurements of the starting height, the maximum height, and the total distance travelled. The starting height is 0.73 metres. The maximum height reached by the shuttle is 2.25 metres. The horizontal distance travelled by the shuttle is 6.32 metres. This information helps us to create a model, a quadratic curve with equation y equals minus 0.187x squared plus 1.0666x plus 0.73. The y-axis represents vertical height and the x-axis represents the horizontal distance.
Then, we consider just the vertical movement of the shuttle, and we can plot this against time. The total time for the shuttle to hit the ground is 1.24 seconds. This gives us a curve of y equals minus 4.8588t2 plus 5.4362t plus 0.73, where y is the vertical height and t is the time. The velocity of the shuttle is equal to the gradient of the curve, so we can differentiate the curve to find the velocity. V equals minus 9.7176t plus 5.4362, where v is the velocity and t is the time. We can plot this on a graph. The gradient of the graph is equal to the acceleration. Using the y equals mx plus c format, we can tell that the acceleration is equal to minus 9.7176. As the shuttle is decelerating due to gravity, our value of g is therefore 9.7176. The actual value of gravity is 9.80665.
The principal reason is that shuttlecocks do not move precisely in a parabola because their design makes them decline more steeply than they ascend. The centre of mass, the cork, differs from the centre of pressure closer to the centre of the skirt, and so the shuttlecock flips itself to stabilise, with the cork leading the direction of travel. Thus the shuttle declines steeper than it rises. And so, the motion of the shuttlecock in the video is not a precise parabola, and because we assumed that the motion was a parabola and only made our calculations using the starting height, maximum height, and the total distance travelled, our model is not exact to the motion of the shuttlecock in the video.